So now the next thing what we have to discuss, keep subheading sorted map. Sorted map. Sorted map. So do you know sorted map is the child interface of what? Map. We covered already. Sorted map is the child interface of map. Can you tell when we should go for sorted map? The name itself indicates, have you observed? If you want to represent a group of key value pairs, so it is a map, a group of key value pairs, all entries will be inserted according to some sorting order of keys. Okay, remember, sorting is based on the key or based on the value? Sorting is based on key. So if you want to represent a group of objects as key value pairs, a group of key value pairs according to some sorting order of keys, then we should go for sorted map. Okay, this is, so make sure you should aware at this point. Sorted map, it is the child interface of, it is the child interface of, it is the child interface of map, it is the child interface of map, child interface of map. Next up, if we want to represent a group of objects as, if we want to represent a group of objects as a group of key value pairs, a group of key value pairs according to some sorting order, a group of key value pairs according to some sorting order, then we should go for according to according to some sorting order of keys, then we should go for sorted map. Sorted map. So here have you observed, sorting is based on the key or based on the value? Sorting is based on key but not based on value. Okay, add sorting is based on the key. Sorting is based on the key but not based on value. Sorting is based on the key but not based on value. Sorting is based on the key but not based on value. Okay, that's all. So now the next terminology, and I make sure you people should have clarity. Okay, next one a bit important here. See, in the last session somewhere we covered sorted set. Have you remembered? Sorted set is the child interface of set, and the sorted set contain some specific methods are there. Have you remembered? There are 6 methods we covered. What is the first? What is the last? Head set, tail set, subset, comparator, right? Okay, these same methods available even in sorted map also. Are you getting? Sorted map, same methods are available even in the sorted map also. Suppose here just observe, it is my key value. Of course here just observe this one. Sir, it is my map object, right? Now observe 101. Okay, some A I am taking. Next 103 B, 104 C, 107 is nothing but some D, 125 is the E, 136 is the F. Can I use the term, is it a sorted map or not? Sorted map or not? Yes. All entries are inserted based on sorting order of keys. Are you getting? 101, 103, 104, 107, 125, 136 sorting order based on the sorting order of keys. Now my target is, sir, can you tell what is the first key? What is the first key? What is the first key? 101. What is the last key? 136. Are you getting? Sir, if you want, you can ask, what is the first key? Anna, what is the first key? 101. What is the last key? What is the answer? 136. Okay, 136. Sir, can you tell what is the head map? If it is a sorted set, what is the method we have? Head set. But here head map of 107. Head map of 107. Do you know it returns a sorted map whose keys are less than 107? Whose keys are less than header part of 107? Can you tell what the answer now? What the answer? Curly brace open. 101 is equal to A, 103 is equal to B, 104 is equal to C. That's all. Are you getting? Like similarly, if the head map is possible, then tail map of 107. Tail map of 107. Have you observed? It returns a sorted map whose keys are greater than or equal to. Have you observed? End conditions greater than or equal to 107. Can you tell what the answer now? 107 is equal to D, 125 is equal to E, 136 is equal to F. Are you getting? 136 is equal to F. So head map, tail map. Next one, sub map. Sub map of 103, 125. 103, 125. It return sorted map whose keys are greater than or equal to 103 but less than 125. Greater than or equal to 103 but less than 125. Can you tell what the answer now? 103 is equal to A, 103 is equal to B, 104 is equal to C, 107 is equal to D. Like, are you getting? First key, last key, head map, tail map, sub map. Last one, do you know? Here comparator method is also there. Comparator to returns comparator object. Comparator method returns comparator object. So if we are following default natural sorting order, yes, default natural sorting order, then comparator method returns what? Null. Have you remembered this part also we covered? Because default natural sorting order of keys, ascending order only. That's why null we are going to get. These are 6 methods are specific methods to sorted map. Is it clear? Right? Sorted set contain which method? Exactly same methods are available even in the sorted map also. Okay. Add. Sorted map defines. Sorted map defines. Sorted map defines the following. Sorted map defines the following. Sorted map defines the following. The following specific methods. The following specific methods. The following specific methods. Following specific methods. Okay, take these methods first. Object first key. Object first key. Object last key. Object first key. Object last key. Next, sorted map. Head map of object key. Sorted map, head map of object key. Next, sorted map, tail map of object key. Sorted map, sub map of object key 1, object key 2. Next, comparator like these 6 methods. Take clearly those 6 methods. Object first key, object last key. Next, head map, tail map, sub map. Head map, tail map, sub map. Next, comparator. Comparator like. I hope clear for all of you, right? These are various methods present in clear, I hope. And then after taking these methods, better to take this example. So take this diagram. For this diagram, the results. First key 101. Last key 136. head map of 107. Comparator itself is nothing but null. Completed, I hope. First key, last key, head map. Next tail map, sub map. Next comparator, null. Okay. Completed, I hope. Okay, so clear for you, right? 101 is nothing but A, 103 B, C, D, E, F, like. So that's all. This is about sorted map. Okay, now keep subheading. Anyway, just a navigable map at last I will cover as 1.6 version enhancements. Better to go for what? Tree map, implementation class for sorted map. Tree map, keep subheading. Tree map, tree map. Okay, at the point, well, tree map under that first point, tree map. Can you tell what is the underlying data structure for a tree map? Underlying data structure. Here, legend this one. Underlying data structure is, do you know what is this one? Red, black, tree. Okay, red, black, tree. Underlying data structure for tree map is nothing but red, black, tree. Okay, this is it's a one type of data structure. So next, can you tell insertion order is a preserved or not? Not preserved. Next, all elements will be inserted according to some sorting order of keys. Okay, sorting order of keys, but not values. Remember this one. Sorting is defined only based on the key. Next, duplicate keys are allowed or not allowed? Not allowed. But duplicate values are allowed, no problem at all. Next, make sure null. Okay, null acceptance. There is a small rule is there, that part I will discuss. First, let me talk about heterogeneous objects. So 1 minute. With full maturity level we can able to tell, because we discussed already tree set in detail. If we are depending on default natural sorting order, then the keys should be homogeneous and comparable. Are you getting? If we are depending on default natural sorting order, keys should be homogeneous and comparable. If we are defining our own sorting by comparator, then the keys need not be homogeneous, need not be comparable. Comparable, homogeneous is not required, right? Okay, this is. So, but what about values? Values, no restrictions. Any heterogeneous objects you can take, or non-comparable objects you can take, because comparison is happened based on the key, but not based on the value. That's why values wise no restriction, right? Is it clear? Next, null acceptance as a separate heading I will discuss. First, add up to this. The underlying data structure is red, black, tree. Underlying data structure is red, black, tree. Red, black, tree. Red, black, tree. Red, black, tree. Next, second insertion order is not preserved. Insertion order is not preserved. Insertion order is not preserved. And it is based on hash code. And it is based on some sorting order of keys. Sorting order of keys. Next, third one. Duplicate keys are allowed or not allowed? Duplicate keys are not allowed. But values can be duplicated. Duplicate keys are not allowed, but values can be duplicated. Okay, next one. Can you tell heterogeneous objects are allowed or not allowed? Here just observe. If we are depending on default natural sorting order, compulsory the keys should be homogeneous and comparable. Otherwise we will get class cast exception. Okay, this. But if we are defining our own sorting by comparator, then the keys need not be homogeneous, heterogeneous objects you can add, and the non-comparable objects also you can add, but based on your compare method logic, so the sorting is going to be happen. Okay, at this point, if we are depending on default natural sorting order, then keys should be homogeneous. And comparable. Otherwise keys should be homogeneous and comparable. Otherwise we will get runtime exception. Saying class cast exception. Exception. Okay, like next, if we are defining our own sorting, by comparator, then then objects, keys need not be homogeneous. Then the keys need not be homogeneous and comparable. It need not be homogeneous and comparable. We can take heterogeneous, non-comparable objects also. Heterogeneous non-comparable objects also. That's all. Completed, I hope is clear. Next one. So whether we are defining our own sorting or default natural sorting order, what about values, Anna? For values, there are no restrictions. We can take heterogeneous, non-comparable, no problem at all. At the next point, whether we are depending on default natural sorting order, whether we are depending on default natural sorting order, or customized sorting order, there are no restrictions there are no restrictions. There are no restrictions for values. There are no restrictions for values. We can take heterogeneous. We can take heterogeneous non-comparable objects also. We can take heterogeneous non-comparable objects also. We can take heterogeneous non-comparable objects also. Okay, that's all. Now null acceptance keeps abiding. Null acceptance. Okay, null acceptance. Here just observe. Now there is a loophole is there, take special care. Sir, here if my tree set already contain some key value pairs, assume that 101A, 102B is there. Now I am trying to insert T dot put of null comma some Z I am trying to insert. Sir, if I am trying to insert null key, an entry with a null key, but already tree map contains some elements, then what will happen? Sir, I have to compare this null with these keys, because sorting is there. To compare whether null is coming before 101, after 101, comparison must be required. But if you compare anything with null, immediately what will happen? Null pointer exception, right? That's why for non-empty tree map, if we are trying to insert an entry with a null key, immediately we will get what? Null pointer exception, right? Clear for all of you? Condition 1 clear. Now the second, sir, my tree map is empty. Empty tree map is there. First entry, I am trying to insert an entry with a null key. T dot put of null comma A, I am trying to insert. Can you tell is it valid or not? Yes, empty. Now null A valid. But after inserting this entry, if we are trying to insert any other entry, immediately what will happen? Null pointer exception by default we will get. Are you getting? So observe the rules. So for empty tree map, yeah, the first entry with a null key is allowed. But after inserting that entry, if we are trying to insert any other, immediately null pointer exception we are going to get. Clear for all of you, right? Okay, this is. But for non-empty tree map, if we are trying to insert an entry with a null key, null pointer exception, right? These are the rules what you people should aware, okay, regarding null acceptance, right? But last important conclusion here is, so this type of story applicable until 1.6 version only. From 1.7 version onwards, null key, null value, such type of thing not acceptable for a tree map. Okay, this is first add. Keep submitting null acceptance. First one. Point 1. For non-empty tree map, if we are trying to insert an entry, with a null key, if we are trying to insert an entry with a null key, then if we are trying to insert an entry with a null key, then we will get runtime exception saying, null pointer exception. Then we will get runtime exception saying null pointer exception. We will get runtime exception saying null pointer exception. Null pointer exception. Okay. First one. Next, second point. For empty tree map, yeah, the first entry for the empty tree map, yes, the first entry with a null key. Yeah, the first entry with a null key. Is allowed. Yeah, the first entry with a null key is allowed. But after inserting that entry, if we are trying to insert But after inserting that entry, if we are trying to insert any other entry, but after inserting that entry, if we are trying to insert any other entry, then we will get runtime exception. Saying null pointer exception. Then we will get runtime exception saying null pointer exception. Okay, that's all. Take a note. The above null acceptance rule. Rule applicable. Null acceptance rule applicable until 1.6 version only. Null acceptance rule applicable until 1.6 version only. From 1.7 version onwards. From 1.7 version onwards, null is not allowed. Null is not allowed for key. Okay, that's all. So here this is the restriction related to what? Null key. But what about values? Whether it is a 1.6 version or whether it is 1.7 version, there are no restrictions for null values. For value, we can use a null any number of times, no problem at all. Okay, at this point. But for values, we can use a null. Any number of times. But for values, we can use a null any number of times. There is no restriction. Whether it is 1.6 version or 1.7 version. Whether it is 1.6 version or 1.7 version. Whether it is 1.6 version or 1.7 version. That's all. Completed, right? So this is what you people should aware clearly. What is the purpose of? What are various properties related to tree map? And these are things you should aware. Null acceptance, heterogeneous objects like we have. Now keep supporting constructors. Do you know? So in tree set, we covered in the last class. How many constructors are there? Can you please cross check? Tree set constructors. How many are there? Tree set, 4 constructors. So no argument. Second one, comparator. Third one, collection argument. Fourth one, sorted set argument. Yes. Okay, like same constructors by default available even in the sorted map also. Are you getting same constructors available even in the tree map also? So the first constructor, okay, tree map T is equal to or M is equal to new tree map M or T, any word you can use. Tree map T is equal to new tree map. Creates an empty tree map where the elements will be inserted according to default natural sorting order of keys. Are you getting default natural sorting order of keys? Okay, this same. Second one, tree map T is equal to new tree map of can you tell what is the constructor? New tree map of comparator C. Do you know this constructor meant for what? Customized sorting order. Okay, like third constructor, tree map T is equal to new tree map of, not tree map t is equal to new tree map of, okay, interconversion between map objects. It's not collection, map objects, right? Map m. For the given map, can you please create an equivalent tree map? It may be hash map or linked hash map, identity hash map, any map object. Can you please create an equivalent tree map? Is nothing but like. Now, tree map t is equal to new tree map of, tree map t is equal to new tree map of sorted map m. For any sorted map, an equivalent tree map by default we are going to create. Are you getting? Total how many constructors are there? 4. The first constructor meant for default natural sorting order. Second constructor meant for customized sorting order. Remaining 2 things are nothing but aware. Okay, at this point. Constructors like constructors. So just you can take from the screen. Tree map t is equal to new tree map for default natural sorting order. First constructor. Tree map t is equal to new tree map for default natural sorting order. Next, tree map t is equal to new tree map of comparator c for customized sorting order. Next, tree map t is equal to new tree map of sorted map m. New tree map of sorted map m. Tree map t is equal to new tree map of map m. Map m. Completed, right? That's all. These are the 4 constructors we have related to tree map. Okay, so just let me go for a simple program, okay, for the tree map, default natural sorting, customized sorting, like I will explain with examples, right? Let me talk about first example. Here see, tree map m is equal to new tree map, and here just observe, tree map m is equal to new tree map. Can you tell, is it for default natural sorting order or not? Is it for default natural sorting order or not? Yes. Sorting order is based on the key or based on the value? Based on the key. Remember. Now, m dot put of 100z, 103y, 101x, 104, 106. Sir, keys should be homogeneous. Values can be heterogeneous. No problem at all. Now, SOP of m. Do you know? Can you tell what the answer we are going to get now? SOP of m. First, which one will come? 100 is equal to z, comma. What the next one? 101 is equal to x, comma. What the next one? 103 is equal to y, comma. What the next one? 104 is equal to 106. 104 is equal to 106. Okay, like we are going to get the output, right? Okay, this is, now let me consider, let me execute this code. What the output by default we are going to get here is Java C tree map demo 3.java. Yes. Next, Java tree map demo 3. Have you observed 100, 101, 103, 104? Correct or not? Okay, this is. But here just observe, if I am trying to insert heterogeneous keys, because we are depending on default natural sorting order, if I am trying to insert heterogeneous keys, because keys are integer type, but suddenly I am trying to add string type, what will happen? Class cast exception, right? Whether we are getting or not. Yes, here have you observed? So what exception? Class cast exception we are getting. Okay, this is. Now let me comment. M dot put of null. Sir, null key. Is it possible or not? No, because already tree map is empty. Empty. For the tree map already contains some element. For non-empty tree map, if you are trying to insert an entry with a null key, comparison must be required. If you compare anything with a null, immediately null pointer exception by default we will get. Are you getting? Null pointer exception we are going to get. Any explanation is required now? Okay, that's all. Take this example anyway. Example or otherwise keep submitting. Demo program for default natural sorting order. Demo program for default natural sorting order. Demo program for default natural sorting order. Completed, right? Take the output also. Completed, right? Okay, the output we are going to get here is so like 10, 100 like we are going to get. Completed, I hope. Okay, next another example, just observe this one. Now here see, tree map T is equal to new tree map of new my comparator. So demo program for customized sorting. Here keys are what type? Keys are what type? String type. Values are what type? Integer type. Now public int compare. How the compare method is implemented is return s2 dot compare to of s1. Sir, can you tell s2 dot compare to of s1? Okay, what it means, Anna? Reverse of alphabetical order. Reverse of alphabetical order means, can you spell out what the answer we are going to get now? What the answer? Z is equal to 30 comma x is equal to 10 comma what the next one? L is equal to 40 comma what the next one? A is equal to 20 by default we will get. Are you getting? Sir, customized sorting, how we can by using comparator concept, how the compare method is implemented based on that. Okay, this is now here see, let me consider what is the name of this program. Tree map demo dot java. Okay, well, tree map demo. What the output is, have you observed? Z X L A itself is the output, right? Okay, this is Z X L A is the output. Okay, take this example. Add heading demo program for customized sorting. Demo program for customized sorting. Demo program for customized sorting. Take this example well. Import java.util.star class tree map demo. Clear, I hope. Take t dot put off